Good morning, students. How are you doing, all of you? Hope you have understood what we learned yesterday. Today we will start with other questions of the exercise. So let's start. Question number 7. Trace each figure and draw the lines of symmetry, if any. So you have to trace the figures and draw the line of symmetry. So you can take a butter paper and trace the figures. So here is the tracing paper I've taken, and here is your figures. So first figure you can check out. The first figure is this, and you have to draw the line of symmetry. So by the observation you have to see that at what direction does we should fold the paper to get the line of symmetry. So you can see that a bigger box and a bigger box here. So line of symmetry would be vertical, crossing the midpoint. So this is the line of symmetry. In the first figure. Similarly, the second figure, what is the line of symmetry? If I draw the first vertical line, then two blocks would be right side and one block would be left side. So it is not symmetrical. However, if I take the second box and the mid of the box, then you can have a symmetrical figure. So always remember that there can be more than one line of symmetry. So this is first line of symmetry. Hope it is visible to you. So let me draw it roughly on the board also. The figure is somewhat like this. So first line of symmetry would be midpoint of the second box like this. Then when you overlap the first part, it would totally overlap the second part. So this is the first line of symmetry. If I go to the third box, then it won't be line of symmetry because most of the part would be on the left side. So this is the first line of symmetry. Then the second line of symmetry would lie in the horizontal direction, because that would make all the upper portion can go below and it would be symmetrical. So this is the second line of symmetry. Then we have a figure like this, and the figure is like this. Now from where would you find the line of symmetry? One would be, of course, the horizontal one. If you draw a horizontal line like this, the upper portion will totally, and fold it along this direction, the upper portion will totally overlap the lower portion. So this is first line of symmetry. And then second line of symmetry would be vertical. This would be the second line of symmetry. Right left portion would overlap the second portion. Always remember these symmetries are the reflection symmetries. This we had studied earlier also. These are the reflection symmetries because they appear the way they would appear. One part is the mirror reflection of the second part. So these are also called as reflection symmetries. Then the next figure is somewhat like this. So how would it, one would be the vertical symmetry. So this is line of symmetry 1. And then the next is the horizontal symmetry, which is line of symmetry 2. Okay, so in this way you get the line of symmetries for the figures. Then there are figures shown on the blocks. So let us start with the blocks. Here for the reference I have made a block. So let's draw some figures over it, like the first one. Let us do the first one later on. Let's draw the second one. It is 2 blocks in the horizontal direction, then 2 blocks in the vertical direction, then 2 blocks here, then 2 blocks here, sorry, this figure has it is like a bit mistaken. Let's draw it over here. Two blocks here and then 2 blocks here, then 2 blocks here, then 2 blocks this way, 2 blocks here, So this is the figure. Now you have to find the line of symmetry for this figure. The line of symmetry, obviously one would be vertical. First of all, let's see the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides are there. So first symmetrical line would be this, between the midpoint of the sides. Okay, we are starting with the sides. So first side is here. Then second line of symmetry would be the corner, this corner with this corner. So this is the second line of symmetry. Then third line of symmetry would be the opposite corners. Then fourth line of symmetry would be this. Fifth line of symmetry would be another corner. This is the figure that we get. Now in this one, this is not any line, just overlook it. The outer boundary is the figure that we get. Now we have to draw the line of symmetry. So of course, if I make a horizontal corners here, then very small portion would overlap the other. So the line of symmetry lies in the horizontal line, which is one line of symmetry. So this figure has one line of symmetry. So in this way you can get the lines of symmetry. Then the last one is the, let us make a block over here. At a distance, how to make a block at a distance of 1 centimeter, you put the dots. So join them. And in this way you would get the blocks. Similarly, join the horizontal points. like this. So here you have been given the figure of a star. So let's make a star. So star is somewhat like this. So the next question, you have a star. So what would be the line of symmetry for a star? It would be, one is the vertical line of symmetry, other would be the horizontal line of symmetry. It would divide into symmetrical parts. Then the center portions where you have the corners of the star, third line of symmetry, and the fourth line of symmetry. So there are total 4 line of symmetries in a star. Lines of symmetry. Now we come to the last part. The first part which we had skipped. So let's draw the figure first. This is the smaller square with a middle division joining the sides, then a larger square, so what are the line of symmetries? One is the vertical line of symmetry, other is the horizontal line of symmetry. So it would divide the both squares into equal parts. Then if you join the corners diagonally, then this is the third line of symmetry. And if you join the fourth part, it would be fourth line of symmetry. So in this way you get the total 4 lines of symmetry. So there are total 4 line of symmetry. Now next is question number 8. Find the lines of symmetry for column. So basically you have to trace the column. So here I have traced it already on the butter paper or the trace paper you can take. Now you have to find the line of symmetries here. This is the column. First line of symmetry would be the center portion here, it would go like this. First line of symmetry, then the second line of symmetry here. This is the second line of symmetry. I should bring the so you can see from here where I have drawn the line of symmetries. One is this line of symmetry joining the center of the stars of one side of column. Then the second side of column, you can divide it like this. Similarly, you can take the horizontal side and draw the third line of symmetry like this. This is the horizontal line, third line of symmetry. Then the fourth line of symmetry would be this one, and fifth line of symmetry would be along the smaller side. This is the smaller box. This is the fourth line of symmetry, and along this side would be the fifth line of symmetry. Then there is one more block here. You would get the sixth line of symmetry for this. So this is your column, and you get total of 6 lines of symmetry. You can count 1, 2, 3, 4, 5, and total of 6 lines of symmetry in the column. So in this way you would get the number of lines of symmetry in a column. Now we move to next question, which is question number 9. Draw the following: a triangle with exactly one line of symmetry. Now this is a bit conceptual question. There is a concept behind it. What type of triangles you can have? One is the equilateral triangle, which we made yesterday with, what was the property of equilateral? That all the sides are equal. So you have an equilateral triangle, and how many equilateral? Again I am explaining here. Equilateral means equal sides. So triangle have 3 sides. So 3 equal sides are there in equilateral triangle. So in that case, what were our line of symmetries? When we take the midpoint of a side and join it with the corner vertex of one opposite to it, then you get one line of symmetry. Then second line of symmetry. Then third line of symmetry. You got 3 lines of symmetry in equilateral triangle. Okay, now here it is asked a triangle with exactly one line of symmetry. So if I take 2 sides equal, let me take 2 sides equal. And the third side is, I take it unequal. Okay, third side is not equal to the 2 sides. This is 5 centimeter, this is 5 centimeter, this is 5.2 centimeter. Or I can also make it a bit bigger so that you understand. Let me draw this like this. Now you can easily see that two sides are equal, but the third side is very long as compared to two sides. So what would happen in this case? When would you get the equilateral? When you overlap one portion over the other. So we will find the midpoint of the third side. So it is around 7.5. So it is around 1, 2, 3.2 would be the midpoint. And when you join this with the opposite vertex, then you fold it and you would get the overlapping side. Now to show it, let us draw it over the piece of paper so that you can understand what we are doing right now. Let's make the triangle. So this is the triangle that we have made with two equal sides and one unequal side. Now if I take the midpoint of the third side, let us take the midpoint. Third side is of 5.5 centimeters. So midpoint would be almost 2.2 centimeter. So let's first find the midpoint of the 2.75 centimeters. So we take 2.7 and draw the. So this I have drawn. Now when you fold it along this line, this from the vertex joining the midpoint of the third side. So when you fold it along, you would get the overlapping sides. So in this way we would get the first line of symmetry, which is not vertical. It would be somewhat it will not be vertical, it would be slanting in a manner. Now if I take other corner and draw the midpoint of the other two sides which are equal, so in that case you would see that the overlapping doesn't occur. Let me make the other side. This is the other side I have taken. This is the side and I have found the midpoint of this side. Now if I turn the fold along this line, you can easily see that the overlapping doesn't occur. So this means this is what type of triangle? Where two sides are equal. So along the midpoint of two sides of equal, the symmetry is not taking place. Similarly, the second equal side which we have, we take the midpoint of that side and try to fold it. So when you try to fold it along the third side, again you would see that there is no overlapping. Lot of portion is left behind for the second part. So this means that this triangle has only one line of symmetry. This is not the line of symmetry. You can say this is not the line of symmetry. This is not the line of symmetry. It is only one line of symmetry. And which line it is? The unequal line. The line which is unequal, that line would get the symmetry. When you fold the paper along that line, it would be symmetrical. And so this type of triangle, you can say that triangle with two sides, with two equal sides, has one line of symmetry. Okay, so triangle with two equal sides have one line of symmetry. And then it is a triangle with exactly three lines of symmetry. So this we have already done. The equilateral triangle has three lines of symmetry. So this becomes the first part, this becomes the second part. Then the third part is a triangle with no line of symmetry. For a triangle with no line of symmetry, we should have, when all the sides of triangle are unequal, then you get the triangle with no line of symmetry. So you can write with all sides of triangle having different length has no line of symmetry. So in this way, this is done with this question. We are done with this question. So rest of the questions we will do in the next class. So I take your leave. I wrap up here only. Take care. Bye, students.